Reimer Tíemann reaction. So in Reimer Tíemann reaction, the reactant involved is phenol. We take phenol. Okay. So in Reimer Tíemann reaction, phenol it reacts with chloroform. The formula of chloroform is CHCl3. So phenol it reacts with chloroform, and in this reaction we use base also alkali. So here the alkali used is KOH or NaOH we can use. Phenol in presence of alkali it reacts with chloroform, and this reaction generally takes place at the temperature 60 degrees approximately. So in this reaction the product formed is like this. On benzene ring OH group is present, and here the substituted group is CHO. It is the major product formed in this reaction. So on benzene ring OH group and CHO group, two groups are present. In these two groups, here CHO can be considered as functional group, OH can be taken as a substituent. According to priority order, OH and CHO in these two groups, CHO can be act as functional group, OH can be present as a substituent. So whenever OH can be present as a substituent, it is called hydroxy, and it is present at ortho position. That's why if you want to write this name, OH group is present at ortho position, so we write like this, ortho, and here OH it is called as hydroxy group, so it is ortho hydroxy. And on benzene ring CHO group is present. CHO it is aldehyde group, it is present on benzene ring, that's why it is called as benzaldehyde. So the major product formed in this reaction is called as ortho-hydroxy benzaldehyde. Right, now you see this ortho-hydroxy benzaldehyde, it's having another name, that is salicylaldehyde. Ortho-hydroxy benzaldehyde, it is also called as salicylaldehyde. And here the byproducts are potassium, it is combined with chlorine, it can be formed as KCl, and remaining hydrogens and oxygen can be eliminated as water. In balancing, here 3 chlorines are present, only 1 potassium is present, that's why we take 3, and here 3 KCls are formed. And when you see number of oxygens, 1 plus 3 4, total 4 oxygens are present, 1 plus 1 2, and here we write 2. Now it is balanced. Okay, so it is Reimer Tíemann reaction. In this reaction, phenol it reacts with chloroform in presence of alkali. The product formed is ortho-hydroxy benzaldehyde. It is the major product. Okay, right, and you see it is an example for electrophilic substitution reaction. Reimer Tíemann reaction is an example for electrophilic substitution reaction, and in this reaction on phenol, in this phenol the group present is OH group. This OH group is electron donating group. In phenol OH group is present. This OH group can be act as an electron donating group. So whenever electron donating group is present in electrophilic substitution reactions, that electrophile can be substituted at ortho and para positions. Okay, so here meta position is not formed here. The substitution can be takes place at ortho and para position whenever electron donating group is present. This electron donating group also act as ring activating group. Okay, so whenever ring activating group or electron donating group is present on benzene ring, electrophile can be substituted at ortho and para position. So here phenol in this reaction, ortho and para, two products are formed. In these two products, ortho is the major product and it is called as salicylaldehyde. It is an example for electrophilic substitution reaction. Okay, now we can see how this reaction can be takes place. For that we studied the mechanism. Okay, now you see the mechanism of Reimer Tíemann reaction. So in this mechanism, first we can take chloroform. So first one is formation of electrophile, because it is an electrophilic substitution reaction. So electrophilic substitution reaction means first we can study the formation of electrophile. Okay, so that's why I write here mechanism. Within the mechanism, first we take chloroform. So chloroform it is present like this. Okay, right. In first here it is first reacted with alkali. Alkali means it is a base. From that base we take OH minus. So whenever the reaction is takes place in between these two, hydrogen can be eliminated from chloroform as H plus. It is combined with OH minus. So here elimination of water molecule, removal of water molecules takes place, and it is a fast step. It is a fast step reaction. So hydrogen can be eliminated as H plus. By removing hydrogen as H plus, carbon contains negative charge. So it is present like this, Cl, C minus, Cl and Cl. Okay, and next step it is slow step. Within this slow step, one chlorine can be eliminated as Cl minus. Okay, total 3 chlorines are present. In these 3 chlorines, one chlorine can be eliminated as Cl minus. Okay, now carbon contains only 2 chlorines. and here this carbon also contains 2 electrons. That means one lone pair can be present because total 4 bonds, 2 groups can be eliminated. That's why carbon contains 2 electrons. Okay, if you write this, we have to write like this also, CCl2. Now carbon, one lone pair is present. Okay, if you want to write this name here, CCl2, it is called dichlorocarbon. Actually CH2 it is called as carbene. CH2 is carbene, but in place of 2 hydrogens, chlorines are present. That's why it is called dichlorocarbene, and this dichlorocarbene contains total 6 electrons. Okay, in this bond 2 electrons, 2 electrons, 2 plus 2 4, 4 plus 2 6 electrons. Okay, dichlorocarbene contains only 6 electrons. That means it is not having octet configuration. Octet means presence of 8 electrons, but here 8 electrons are not present. That's why it can be act as an electron deficient compound. Here electron deficient compound means which is not having 8 electrons. Okay, here only 6 electrons are present. That's why it is an electron deficient compound. Electron deficient compound means it can be act as Lewis acid. Lewis acid is electron deficient compound, and these Lewis acids can be act as an electrophile. So in this reaction, in Reimer Tíemann reaction, this CCl2 can be act as an electrophile. Actually nucleophile contains lone pair. Any compound if it contains lone pair, it can be act as nucleophile, but here octet configuration is not present. That's why even though one lone pair is present, here CCl2 dichlorocarbon can be act as electrophile. You remember this. Okay, and you see here we take chloroform. From this chloroform, one chlorine and one hydrogen, these two can be eliminated. Okay, so it is an example for elimination. Here elimination step is takes place, and the elimination is called alpha elimination. Okay, remember this. In the formation of dichlorocarbon, elimination is takes place, and here the elimination is alpha elimination. Alpha elimination means the two groups can be eliminated from same carbon atom, then it is called alpha elimination. Okay, so here these two groups can be eliminated from same carbon atom. That's why it is called alpha elimination. So in the formation of dichlorocarbon, that elimination involved is alpha elimination, and in Reimer Tíemann reaction, CCl2 dichlorocarbon can be act as electrophile. Okay, now we can see how this electrophile can be substituted on benzene. Okay, so here it is a formation of electrophile. After formation of electrophile, we take phenol. So you see, first we can take phenol. So in this phenol, it is having weak acidic nature. So that's why phenol also having some acidic nature means here phenol, it can be lost one hydrogen because it is having some acidic nature. So by the elimination of hydrogen, it can be present as O minus. Here H plus can be released. Okay, it is called phenoxide ion. So in this, before substituting electrophile, phenol can be formed as phenoxide ion. Okay, that electrophile can be substituted as phenoxide ring. Now we take this phenoxide. After taking this phenoxide, on this phenoxide, this electrophile can be adopted. Okay, so here it is electron donating group. That's why it is takes place at ortho and para position, and your major product is ortho product. That's why here you studied about substitution at ortho position only. Okay, so here you see this is shifted this side. So in between carbon and oxygen double bond is present, and this bond it is shifted this side. Here this CCl2 group can be substituted. So after substituting CCl2 group on benzene ring, it is present like this. Now that is formed as double bond O. Okay, and here one hydrogen is present, it is belongs to benzene. Now here CCl2 group is substituted. In this, carbon contains negative charge. Okay, so this double bond shifted this side, here hydrogen is present, and CCl2 can be substituted here, and this minus charge is present on this carbon. Okay, and next step you see again this double bond shifted this side, oxygen contains negative charge, and this hydrogen shifted, this bond shifted this side. Here single bond can be converted into double bond. Okay, so again it can be formed like this. Here it is present as O minus. Now here CHCl2 is present, and here it is present like this. Okay, so again 3 bonds are present within the ring. Here CHCl2 is present. After formation of this, here it is reacted with 2 moles of base. On reaction with 2 moles of base, in place of 2 chlorines, 2 OH groups can be substituted. Here the chlorines can be removed as 2Cl minus. Okay, so after this the compound can be formed like this. It is present like this. Here within this triple bond is present, O minus. Now you see here carbon, hydrogen, and here two OH groups are present. That means in place of two chlorines, here two OH groups can be present. Okay, whenever on carbon two OH groups are present, it is unstable. That's why after formation of these from this group, here water molecule can be eliminated. Okay, here OH, two OH groups are present. In these two OH groups, water molecule can be eliminated. Now this bond shifted this side. Here 2 moles of water eliminated. After eliminating water molecule, 1 mole of water molecule. Here in between carbon and oxygen, double bond is present. Okay, so it can be formed like this. You see here O minus, and within the ring triple bond is present. Now it is present like this, CH, and in between carbon and oxygen double bond formation is takes place. So it is nothing but CHO. CHO means aldehyde group. Okay, right. After this here O minus it is reacted with H plus, which is released in first step. This H plus can be again reacted with this oxygen O minus. Now this O minus can be converted into OH. Okay, so the final product it is formed like this. So on here OH is present and here CHO is present. Okay, it is nothing but orthohydroxybenzaldehyde, which is called as salicylaldehyde. Okay, it is a preparation of salicylaldehyde by using Reimer Tíemann reaction. In this reaction, you remember thus the temperature used is 60 degrees and the major product is ortho product, and in this reaction the electrophile involved is dichlorocarbene. Actually it is contained a lone pair. Generally lone pair is present, it can be act as nucleophile, but here dichlorocarbene it contains electrophile even though it acts as an electrophile because it is an electron deficient compound. Okay, and here the major product is ortho product, the product is salicylaldehyde. Okay, and in the formation of electrophile, that step involved is alpha elimination. In alpha elimination, two groups can be eliminated from same carbon atom. Okay, so it is overall Reimer Tíemann reaction.